Hi everyone. Today we are going to be going over lesson 40 for our 8th grade Elevate groups, which is on locating and finding the distance of points on the coordinate plane. We are going to be doing this lesson before lesson 39 only because it follows a more natural progression of the skills that students are required to master over the next few days. So we start out with about 2 minutes of you going into your introduction, paying close attention to the vocabulary words that students are going to be using the next few days, and then highlighting how students should graph ordered pairs. So this lesson teaches students that in graphing an ordered pair, they are always going to start out at the origin, which is 0, 0. So if students wanted to plot 2, 3, they would need to know that the x-axis goes from left to right, and then the y-axis goes up and down, right? So the x-axis is always aligned with our first number, which is our x-coordinate, and then our y-axis is always aligned with our second number, which is our y-coordinate. So if we were going to plot 2, 3, starting at the origin, we would move 2 spaces to the right, and then from there go up 3 units. That takes us to P. So once you stamp that knowledge for students, you can launch them into a turn and talk. Given what we just spoke about ordered pairs, describe how you would plot the ordered pairs 1, 4 and 4, 1. Now, depending on the level of engagement in your classroom, you might want to go ahead and have one half of the classroom plot 1, 4, and then the other half of the classroom plot 4, 1, and have them engage in discussion. Do both points end up in the same place on the coordinate grid? And if not, why not? Students should be able to identify that because even though they have the same digits, because their x and y coordinates are different, the order in which they need to follow is also different. And so then you will jump into a more concrete model on how to identify the ordered pair when given a point. So here we have point A. Using the same knowledge that we talked about earlier about left to right and up and down, students will always start at the origin. They will see that in order to get closer to A, they would have to move 1, 2, 3 units to the right. They're still not at A yet. So even though they moved the 3 units to the right, giving us our x-coordinate, they would then have to move 1, 2, 3, 4 units up, giving us our y-coordinate. And then the second model you're going to jump into is the opposite of the model that you just did. This time you are going to be given the ordered pair. You're going to have to plot it. So 6, 2. We know that our first coordinate goes along the x-axis. So 6 units to the right, that's 1, 2, 3, 4, 5, 6. And then our y-coordinate tells us that we need to move 2 units up. So that's 1 and 2, landing us right here. Please get into the habit during your model of not only just plotting the point, but also writing the letter that they've asked of you. So make sure that you put the point, but then also physically write the letter B. And then here's another opportunity for a turn and talk just to stamp for kids that order does matter. So it says that Marnell plotted point M. He said the coordinates of M are 4, 2. What can you tell Marnell about his work? I really would release kids to engage in turn and talk discussion before stamping anything because students might find different paths to answering this question. Some students might see 4, 2 and they might say, okay, well, I want to do what my teacher just taught me. I want to move 4 units to the right and then go 2 units up. Oh, snap. that's not the same place that Marnell plotted his point. And then you might have some students who might say, no, let me figure out what point Marnell did plot. And so they would say, okay, I'm going to move 2 units to the right and then 4 units up. Okay, 2, 4, and 4, 2 are not the same. So he did the wrong order. He swapped the X and Y coordinate. So his work was incorrect. And so from that turn and talk, we released students to about 3 minutes to work on questions 1, 2, 3, and 4 independently. It shouldn't even take 3 minutes, but they can work with a partner if they are struggling. And then you're going to jump into this second part of the lesson that is almost going to highlight what students are going to do tomorrow. So tomorrow's lesson is mainly focused around distance. And so it's okay if students don't necessarily master this portion of the lesson today. However, you are showing them that once they can have multiple points on a coordinate grid, and they will use the grid to find the distance between 2 or 3 of those points. So, for example, it says K's neighborhood has a library, school, park, and pool. How many blocks does K walk to get from the library to the park? It is going to be very important that students use some sort of annotation process to track what the question is asking them to do, right? In this question, as you can see on the coordinate grid, we have 4 different points: park, school, pool, and library. Students are only supposed to be focused on the library and the park. So you can go ahead and tell them maybe put a star at park, put a star at library. And then it tells them that in order to be able to solve this type of problem correctly, they need to know the coordinates of both of those points. So finding the coordinate of the library and then finding the coordinate of the park. From there, they would have to subtract the x coordinates. So here are the x coordinates. 7 take away 2. That gives you 5. Second step would be to subtract the y coordinates, which are these right here. Some students might want to do 1 take away 8. No, absolute value distance can only be positive, so we cannot have negative numbers as it pertains to distance. So it has to be 8 take away 1. That gives us 7, right? So we went 5 units along our x coordinate and then 7 units along our y coordinate. Adding that together gives us a total of 12 blocks in order for you to get from the library to the park. Okay. This model also allows you to show students that they can literally just count the blocks in order to skip all of the addition and subtraction work, right? So this is what I have modeled over here. In order to get to the library, all I did was jump. All I did was jump 1, 2, 3, 4, 5, 6, 7. I'm not at the park yet, but I do need to make a turn. So from 7, 8, 9, 10, 11, 12. So you'll show students both of those strategies for about 3 minutes, and then students will jump into question 1 and question 2, choosing whatever strategy they want to in order to find the distance between 2 points. And then the last thing that they are going to do is a mini exit ticket, very similar to questions 1 and question 2 on this page. The only thing that is different is that each block is equivalent to 2 units, or each unit is equivalent to 2 feet. So students will see here that, okay, they had to move 2 units down and 8 units to the right. However, 2 units down, 8 units to the right, 8 plus 2 gives you 10. But if each of those units is 2 feet, then they would need to do 10 times 2, giving you a total of 20.